All right, one more topic to talk about. Um, this is the notion of compressing a truth table. And we've already seen this when we were talking about multiplexers and trying to describe the behavior of them. And we observed that there was a shorthand we could use in truth tables if we allow the outputs to be something other than just a 1 or a 0. So let's look at an example. Suppose I have a function of three input variables, a, b, c. And let me break this into groups of two sets of input. And let's suppose, our function looks like this. And so we know we can write f as, a sum of products, a bar b c, or a b bar c bar, or a b bar c, or a b c bar. That's very straightforward. But let's see what happens if we eliminate one of our input variables. So what does this look like? Normally we've got three variables coming in and we've got a single output, and each output is listed as a 0 or a 1. All right, so we're going to do something different here. We're going to think of this as a function with only two input variables, a and b. And we're going to think of this as, something that takes in two variables, a, b, and gives us an output. So let's look at our first two rows. Suppose a is 0 and b is 0. So let me make a smaller truth table here. And suppose a is 0 and b is 0. Well, we're either in this row or this row. And if c happens to be 0, f should be a 0. But if c happens to be a 1, well, f should still be a 0. So ignoring c, just by looking at a and b, we can absolutely say for this function, if a is 0 and b is 0, f is a 0. And we don't even have to mention the variable c. All right, let's look at these two rows. In these cases, a is 0 and b is 1. So this is the case, a is 0, b is 1. And now, sometimes f is a 0, sometimes it's a 1. It does depend on c, but how does it depend on c? Well, if c is a 0, our function is a 0, and if c is a 1, our function is 1. So we could, instead of putting a 0 or 1 in this truth table, we could put the letter c. And this means if a is 0 and b is 1, our function has the same value as the input c. All right, let's look at the next two rows. A equals 1, b equals 0. Well, here again, the value of c does not matter because our function is always a 1, so I can put a 1 here. And let's look at our last two sets of inputs. A is 1 and b is 1. And here again, sometimes f is a 1, sometimes it's a 0. But more particularly, if c is a 0, f is 1. If c is 1, f is 0. So f is just equal to the complement of c. So this is a simpler truth table, and this we say we compressed around c. In other words, we removed c from the set of inputs, and we allowed c or its complement to appear in the output column. So we've taken a function of three variables that had 8 rows in the truth table, and we've expressed its behavior in a smaller truth table with only 4 rows, but with the added twist that the output is not always just a 0 or a 1. Sometimes it's also got this c in it. So that's a compressed truth table, and like I say, we saw this when we were looking at the behavior of multiplexers and demultiplexers, where we expressed the behavior of the output in terms of one of the inputs. Right? Remember, we had a select line, and we said if our select line was 0, then the output was whatever was coming in on input 0, and if select was 1, the output was whatever came in on input 1. So that's another example of compression. So this is something we can do with any truth table, and we can compress multiple times. We could compress this truth table around b, and then our function would be something that included b's and c's in the output. And if we do that, we'll get a simpler truth table that only has two rows. A is equal to 0 or A is equal to 1. But the value of the output will be more complex. It won't just be a 0 or a 1 or something with a C or a C bar, but it'll be some combination of zeros, ones, C's, C bars, B's, B bars, with some additional logic operations in. We can compress around all of the variables, and then our output function would simply be the sum of products expression for f in terms of a, b, and c. So that's a concept you can work with in some of the practice problems.